as to follow the instructions with number 1. But I believe, if I am not mistaken, your dot for C is 1 lower than it needs to be. Please put the dot for C up by the letter C. So your work looks like this. I am going to create a black line, and I'm just going to freehand it up here. Okay? You can use a ruler, but it's not really that necessary because that line isn't that important. Now, then I have asked you to connect A to H. So all the way out here. Now here is where I'm going to use 3 different colors. I'm going to use red. Then I'm going to use blue. Then I am going to use green. Now everybody needs to be aware that those 3 colors should all be on the same line. Is everybody cool with that? All right. And then I'm going to use black to connect the vertical ones. Is everybody cool? All right, so everybody's drawn a giant triangle, right? That is split into 3 sections, yeah? Excellent. Okay, now I would ask you, I don't write anything down yet, but what do I mean when I say a ratio? Do not give me an example of a ratio. Tell me what a ratio is.
Comparison between 2 numbers?
It's a comparison between any 2 numbers, yes? Is order important? Yes, because the ratio of adults to children in this room is different than the ratio of children to adults. Agreed? Now, some of you would argue that I do not count as an adult because I behave abominably. That is not the case. We are going chronologically only. I am indeed an adult. Alright? So, how do we normally write a ratio? When you were in grade 3 and Mrs. Bad Crumble introduced the concept of ratios, Brianna, how did she write them?
So like a number like 5 and then like 2 dots.
Colon. Yes, exactly. So in this room, adults to children would be, don't write this down yet, adults to children would be 1 to 30, yeah? Now, hopefully, Mrs. Bad Crumble explained to you that ratios can be written in 3 ways, yes? Words, adults to children. Numbers, 1 to 30. Or what is the other way we can write it? A fraction, 1 over 30. First number is the numerator, second number is the denominator, yes? Okay, now, once we get a fraction, what is your next thing you want to do with that? You want to divide it to make it a decimal, yes? So every decimal is also a ratio. Do you all understand that? All right. Now, I have asked you here, now we're going to start writing, to write the ratio of BF to AF. Where is the line that connects B and F? Find it on your paper. Tell me the distance. 3. So we're going to write it the way Mrs. Bad Crumble wrote it, and A to F is 4, yes? Now we're going to write it the way you learned second, which is 3 over 4, yes? And now, even though you already knew that decimals were ratios, I just probably reminded you of that. We're going to write it the way that we're going to write ratios in grade 10, which is 0.75. Is everybody cool with that? Yes? Excellent. Now, CG for me is this black line, yes? C to G. Everyone agree? Great. How long is that? 9. How long is A to G? 12. Okay, let's rewrite that the way ratios can be written. 9/12. Okay, hey, wait a minute. What just happened there? They're the same thing, aren't they? So what is this guy's decimal? 0.75. Wait a minute, I think something sneaky's happening here. What is D to H? TJ. Damn it, D should have gone one up more. So 15. And what is A to H? That should have gone up one more. I gotta have to erase this line. What a dunderhead. Me. 15 to 20, which is 15/20, which is what? 0.75. Now, all of you should have noticed something. What happened with all those ratios? Jack? They're all the same. Absolutely correct. And they are comparing what parts of the triangle? The vertical one and the horizontal one, yes? The legs. Thank you. I was hoping someone would say it. You. All right. They are comparing the legs. They're completely ignoring the hypotenuse, yes? Now, you guys aren't dumb kids.
Wow.
B to F, C to G, and D to H are all different, aren't they? Right? And A to F, A to G, and A to H are all different, aren't they? But when I make the fraction, they're the same, yes? So that must mean that something between all three of these triangles, the green one, the blue one, and the pink one, is the same. What is the same? They all start here, don't they? So that angle is shared from all three of them, yes? And every time I compare the vertical leg to the horizontal leg, I get 0.75, don't I? Everyone agrees? We've just proven it 3 times, haven't we? What would happen if I took this line right here, A to H, and I walked all the way over to here? And then I took A to D, and I carried on all the way up to the ceiling. What would happen if I compared this to this? I would get 0.75. Does everybody see that pattern? What if I drew this line to the moon, and I drew this line to a point in space directly below the moon? 0.75. What if I drew this line to another star? 0.75. Does the size of the triangle affect this fraction? No. So that means if I can build this triangle on a piece of paper, can I build any triangle with that angle in real life? Yes. That is how trig works. Does everybody understand? So what are we saying here? We are saying that if we compare the legs of different triangles, that start from the same angle, what happens? What do we find? They're not the same size. What did we find that was the same? We find the ratio stays the same. Now, don't write down what I'm about to write down. Just think about it. What if, I'm going to erase this as soon as my computer unfreezes, because, you know. Oh, that was a good one. Stays the same. Now, what if I erase this angle A and I drew a new angle A that went up here and down there? And I compared that vertical and that horizontal, but this is A now. Would I have the same decimal? No, I would not, would I? Why? Because the angle has changed. Does everybody see that? So what does that tell us? That tells us that as the angle changes, what happens to that comparison between the vertical and the horizontal? It changes as well. Everybody cool? All right. So now we're going to do some work with that new piece of knowledge. This is called and my computer has frozen yet again. It's called the tangent ratio. And it is one of the most powerful pieces of math that we have because it allows us to draw pictures this big and build buildings this big. Everybody with me? It allows us to draw a picture on a star map this big and tell that the closest star is billions of kilometers away. It's all trig. Cool? All right. And this holds true for all right angle triangles. And then in this blank spot right down here, in big letters, regardless of side length. Does everybody understand that? That is key. The length of the side, the length of this line and the length of this line do not affect the angle. Does everyone understand that principle? You cannot understand trig if you don't get that. Everybody does? Okay. Now, this is the hardest day of trig because this is the day that we all have trouble learning our calculators. Everybody get your calculator out right now. If you didn't heed my warning from Tuesday and you are still trying to use your phone, today is going to be a giant pain in your butt. My warning on Tuesday was to go out and get the right kind of calculator. The right kind of calculator that makes your life easiest is the kind that is like mine, that when you push the button tan, it writes the word on the screen. If you don't have that kind of calculator, listen to me right now. You are going to need to pay very close attention to how we perform today's calculations, because you cannot enter them into your calculator the way they are written down on the piece of paper. If your calculator writes the word tan, then you are able to do your work the way that it is written, which is easier for you guys to grasp. Okay? All right. Now, a couple of things have to happen with your calculators right now. First of all, does anyone have this giant one like I have? No, you do not. No, you do not. Brianna, you do. Brianna, please push the button on yours that says mode. Top left-hand corner. Now use the arrow keys to go down until the word degree is highlighted. Then push enter. Okay? Then push mode again. I'm sorry. Push enter and then push clear. You are done. Now, everybody else, listen to me and listen to me closely. Don't be the kid that doesn't hear me. Look on your calculator screen. On your screen, I want you to look for one of the following things. My computer is frozen, so I'm going to wait until I have some blank space to work with. I'm going to wait patiently for my new computer to work. I am still waiting. I'm still waiting. I'm still waiting. Now it's at least telling me it's not responding. Now it is responding. On your screen, look closely and see if you can see the letter D or the three letters D, E, G. If you cannot see them, one of those two, put your hand up. If you can't see D or DEG, is there anybody in this room that does not see D or DEG? Two of you? Anybody else? Okay. So Jashin, you are seeing either R and rad or G and grad. As are you, Riley. Am I correct? Thank you. What are you seeing? You've got degree now? It's always one. Everybody has degree, yes? Okay, now that everybody has degree, we can actually do our work. How many people, put your hand up.
You're freaking killing me.
Too loud?
No. That pose.
Oh, I know. Can you believe it? Can you believe that?
They're writing the test over here. I'm laughing my guts out.
I know.
Have you shown these?
No, I haven't shown them. I was going to do it at the end of the day when their brains are mush.
Oh,
Yeah.
I'll bet you that half of them will agree.
Oh, I probably.
Why not?
I hope not, but we're going to try. I'll show you. Relax. All right.
Piques my interest.
I know. Do you like how Mr. DeVries and I do that? All right. Now listen. Guys, this is super easy, but it's super frustrating because you refuse to pay attention to me, like the guys in the back corner right now, who don't even know I just made fun of them. Everybody needs to do this and needs to do it right. Put your hand up if your calculator writes the word tan. Put your hand up if it writes the word tan. Excellent. All of you push the button that says tan. Then, most likely your calculator will put a bracket there for you. If it doesn't, it's no big deal. You then push 35. If your calculator put a bracket, you close the bracket. If your calculator doesn't put a bracket, you don't have to push a bracket. Then you push equals, and you tell me what your calculator says. Nick. 700, and then a bunch more numbers, yes? I only want the first three. Okay, is everybody good? Everybody whose calculator writes the word tan. Everyone is good?
Mine writes 10, but when I do that, I get 0.473.
Then you don't have D or DEG showing. That's why I did that whole thing at the beginning. Pardon? No. Again. Please help him, Jack. Does your calculator have a D on it? Yes. Yes. Okay. So does your calculator, when you push tan, does it write the word tan? Okay, that's not tan. I said if it says the word tan. See, you need to go.
Oh yeah.
You've got to keep. No. It says tan. You just push tan. But you've got that going back. You need to reset your Yes. You have degrees showing. You need to push the button. It says tan, 35, and equal. Don't worry about it. We'll sort that out. Okay, everybody, please. Now, if your calculator doesn't write the word tan, you must reverse this order. You will push 35, then the tan button, and you will not push equals. And your calculator will show 700. Please make sure your calculator can do that. Excellent. Now, tell me what tan of 15 and tan of 45 are. Nick. 0.267. Excellent. And 1. Excellent. Is everybody good? Okay. Now, we know that the tangent ratio compares the vertical leg of... Yes, Riley?
Does not show this. It works for this question. It's different. It's like it's a different model. No, it's the same, but it's like
You believe that the change of
that's not your fault.
there's a way to program that out of your calculator. I just don't know how to do it. Sarah, what does yours show? Brad? Okay. Hi. Okay, guys, bring it back. Bring it back. We know that the tangent ratio is simply a fraction, yes? And the fraction is the vertical leg divided by the horizontal leg, yes? From our first experiment we did. Everyone agrees? So that means this first triangle must have an angle of 35, yes? Because that's the angle, 35 degrees. And if I were to compare this, x, and this horizontal, y, x divided by y would equal 0.700. Does everybody understand that concept? Okay. So what would the middle triangle look like? It would be 15. And what would be the two things I was comparing? The vertical one over the horizontal one. So x divided by y would be 0.267. Everybody understand? All right. And this one would be 45. And x and y, x over y would equal 1. Is everybody good with the concept? Please notice I have put no numbers in, have I? Because I want you to get the concept. Everyone's cool? All right. Now, look down here. First thing I want you to do is get rid of that negative sign. That's not important for you guys. It's a typo. Next thing, please look. Do I have an angle or do I have a ratio? I have the ratio, don't I? Now, you guys are smart kids. If hitting the tan button got me the ratio, then I must be able to work backwards from the ratio to the degrees. Yes? And you do that on your calculator by using the shift tan function. So on most of your calculators, you will push second tan. Or you will push shift tan. or you may have INV, tan. On your calculator, it will show, if it writes the words, it will show tan -1. If you have a backwards calculator, it will not show you anything. So, with the forward calculator, to do this question, you will push second, tan, 0.75, and equals. And what does that give you? 36.8. Do we measure angles in decimals? Does anybody know? No, we measure angles in minutes and seconds, like time. So we don't use decimals. So we're going to round that off to 37. Cool? Now, if you have a backwards calculator, it is reversed. You will hit 0.75 second tan. And you will not have to hit equals, but your calculator will show you 37 degrees. Can everybody do that?
Yes.
Yes? Awesome. Now use your new knowledge to tell me the angle for 1.23 and the angle for 2.5. 51 degrees and 68 degrees. Could everybody do that? Yes. Excellent. So now, in this blank space here, please write the following. Tan finds the ratio. Shift tan finds the angle. Does everybody get it?
Yes, sir.
Okay. Now, you guys are smart kids. If my ratio was 0.75 and that got me an angle of 37, how big was angle A in our very first question? 37 degrees. Because the ratio was 0.75. Does everybody get it? Yes. Okay. Now, we're going to come to our first actual trigonometric concept. Everything else we've done has been background. This is the actual thing right here. For any specific angle in a right triangle, please write here, under specific angle, write not the right angle. This doesn't work for the right angle. The tangent ratio compares the, and I'm going to write words you don't know yet, the opposite over the adjacent. Now, I heard somebody whispering adjacent, so somebody in the room has done trig before. I know that Jack has because I personally taught him. Sooner or later, that'll write out. Adjacent. Now, here's what that means. Over here, just draw a line here that makes the triangle. Okay? How many angles in this red triangle are not the right angle? 2. Everyone agree? So I'm going to go ahead and I'm going to call this angle angle X, because I use a capital letter, yes? And I'm going to call this angle angle Y. Is everybody cool with that? Now, when I am using X, I am comparing the vertical to the horizontal, yes? So I am looking across the triangle. What does across mean now? Opposite. And when I look at this side that is right beside it, I call him the adjacent. Is everybody cool? Because this guy already gets a special name, doesn't he? What's this guy? He's the hippopotamus, right? Mr. Bailey. He's the hypotenuse. So he already gets a special name. He doesn't get to have a second special name. Yes, Carlos? Of course. Now, you guys are smart kids. You're smart kids. What if I want to work with angle Y? Now what is opposite? I got to go down here to find the opposite. And this guy becomes the adjacent. Is everybody cool with that? For some reason, that's where kids get confused. Do you know why kids would get confused there? Because I have never been able to explain it. It's simply this. When I am sitting right here, Jake is opposite me, yes? If I move to a different place in the room, will somebody else be opposite me? Yeah. So if I move to a different place in the triangle, does opposite change? Obviously. And yet, students say, this is so hard, man, I can't do trig, I don't get it. There's only two things that change, don't they? Because does the hypotenuse ever change? No. All right, so now let's see if you really get it. Angle A is where? At the top. So I'm going to draw a picture of a really good-looking guy. That's, of course, me. I am at the top of this triangle. Since I am the one doing the work, my point of view is what matters, doesn't it? So if I want the tangent of A, I know that tangent is opposite over adjacent, yes? So when I am up here, what is opposite to me? 12, because I look across the triangle. What is beside me that isn't the hypotenuse? 5. Everybody cool? Super easy, right? That's a ratio, isn't it? How else can we write a ratio? As a decimal. So what would I do there? That would be 12 divided by 5, which would be what? 2.4. Is everybody good? Are you really good, or are you just saying that so I'll shut up? All right, good. Now, you guys, smart kids, you're so smart it's embarrassing that I have to teach this to you because you should just figure it out on your own. If I slide down the triangle, woo! Now, I am in a new spot in the triangle. Does the triangle look different to me? Yes. I want the tangent of B. Does the tangent change, or is it always opposite over adjacent? Always opposite over adjacent. So, but now, what is opposite? 5 over what? 12. So, what is that? 5 divided by 12. 0.416. That'll do. Is everybody good? Yes?
Would you round in this situation?
Yeah, 3 decimals, usually, in trig. Everybody cool? Now, I now have a ratio. Oh, that's supposed to be highlighted. I would like one, but it took me a year to get this one. Another year to get a new one. Of course it highlighted in red. Why wouldn't it? Okay, now, here is a ratio, yes? Here is a ratio, yes? Okay, now, I want to find angles. So am I using tan or shift tan? Shift tan, yes? So, on my calculator, it's a forward calculator. Do I punch it in the way I see it? Yes. So I go second tan bracket 12 divided by 5 bracket equals. And if I was doing the red one, what would I punch in? Second, tan, bracket, 5 divided by 12 bracket equals. Right? So now I want all of you to do it for your machine. And then I want you to actually do D. Write down the buttons you push for your calculator. And I want you to write them down because I am tired of kids asking me at the end of this unit, how do I get the angle again? After we've done 10 days of practice on it. So everybody is going to write it down here. I'm even going to write it down for myself. On my calculator, which I'm going to show you right here, I need to push second, tan, second, tan. Now, do I need to push the first bracket?
No.
Do some of you?
Yeah.
Yes. I don't need to push the first bracket. So the next button I push is what? 1, 2, 1, 2, divided by 5. Then I must close my bracket. Then I must push enter. So on my calculator, I didn't need to push that first bracket, and my equal sign is enter. Does everybody understand?
Yeah.
Excellent. So you should now be able to tell me what is angle A? 67 degrees. And what is angle B? 23 degrees. Is everybody good? Awesome. Now, be honest. Be honest. Are you okay? Because if you're okay with this, you now have all the tools you need to do everything in trigonometry. That's how easy it is. But people still think it's complicated. So I'm going to show you how to make sure it stays this easy. Everybody cool? All right. Now, the first thing I need to do is tell you something that you don't know. In this space right here, no. You know all the math. You don't know what I'm about to show you. In math class, if we don't know a number, what do we give it? A letter. Not necessarily X, but any letter, right? In math class, if we have an angle, we give it a Greek letter. We give it this. Angles are Greek letters. And the angle that we use, the letter we use, like we always use X in algebra, the letter we always use in trigonometry is a circle with a line through it, which is called theta. Theta. So now you have 3 new terms, don't you? You have theta, you have O, which equals opposite, and you have A, which equals adjacent. Is everybody cool with that? Okay, so now I'm going to show you how to keep trig easy. All right? Here's how you do it. You only have 3 options, right? Theta, opposite, and adjacent. So every trig question, we write theta and then whatever sides we're dealing with. So in this question, do I have an angle that I care about? It's right there, yes? So my theta equals what? X. Everybody cool? Says right there, that angle is X. So my theta equals X. Any problem? Excellent. Now, I look at this triangle and I see the hypotenuse is blank. So screw him. I don't care about him. Right? But I have an opposite of what? 23. And I have an adjacent of what? 15. Now I ask myself, do I need an angle or do I need a side? Angle. What finds angle? Tan or shift tan? Shift tan. So I look at this calculator, this operation here, and because I've written it out, I already know what to do. Tan of x, because I don't know the angle, equals opposite, 23, that's my opposite, over 15, that's my adjacent. And since I need to know the angle, I must do shift, yes? Didn't we just do that twice? Great, do it. Tell me how big angle x is. 57 degrees. Could everybody do it? That's trig. That's trig. Now, if you go home tonight, 9 out of 10 of your parents will say, they'll ask you at dinner, what'd you do at school today? And you'll go, nothing, like teenagers do. But today, say, I learned how to do trig. And most of your parents are like, wow, trig's hard. And you guys will all be like, no, it's not. It's totally just 2 numbers. And your mom and dad will then, if they were my mom or dad, they'd slap you. But, because for disrespect. But you guys weren't raised like I was. You'd get not that. So, let's look at the next one. Do I have a theta that I care about? What is it? No. Thetas are angles. It is 15. Now, once I have decided that that's my theta, that means that's where I'm looking at the triangle. So, I look, I see no hypotenuse, so screw it. But I see I have an opposite of what? No. What does opposite mean? Across. So what do I find? X. What is my adjacent? 37. And what do I know about tan? It's always opposite over adjacent, isn't it? So tan of what? 15, because now I have the angle, equals what? X over 37. How do I get rid of the number down here in algebra? Multiply. Well, isn't all math the same? So in algebra, if I multiply to get rid of a denominator, don't you think I do the same thing in trig? Is trig math? Is math a pattern? Does math make sense? Yes, it does. So I'm going to multiply this side by 37, which allows me to do what? Cancel, cancel. Yes? Now x is by itself. Awesome. But if I multiply the right side by 37, what must I do to the left? The same thing. So the left side becomes 37 tan 15 equals x. Now you guys are smart kids. When there's no operation written there, what operation is it? Multiply. So what do I punch into my calculator? 37 times tan 15. Now, if you have a backwards calculator, it's got to be 37 times 15 tan. And then what do I got to hit? Equals. What's the answer? 9.91. Is everybody cool? Going once. Twice. Yes, Brianna? You did 37. You have a forward calculator. Well, that's why. All right. Now, do not yell out an answer. Just set this one up. Theta, opposite, adjacent. Just set it up, and then I will ask you what you wrote in a moment. While you are writing that down, if you write it down quickly, you can go ahead and solve it, but do not say it out loud, please. Thank you. Would anyone like to volunteer their theta here? Sam? 70. Absolutely correct. Would anyone like to volunteer their opposite? It is 14. What is the adjacent? X. Now, would anyone like to volunteer the equation they wrote? Tan 70 equals 14 over X. Now, you guys are smart kids. Algebraically, we would cross multiply here, wouldn't we? Because this is tan 70 over 1, isn't it? So I would do 14 times 1. Do I have to do 14 times 1? It's 14, isn't it? And then I would divide by tan 70, wouldn't I, if I was doing algebra? So since we already know that, we can just do the shortcut, can't we? We know that it's going to be 14 divided by tan 70. So we write out 14 divided by tan 70. That equals X. How do you do that on your calculator? Same way you did it with times, except instead of hitting times, what do you hit? Divide by. So it's 14 divided by tan 70 equals, or it's 14 divided by 70 tan equals. What's the answer? 5.09. Can everybody do trig? Yes. I'm not lying to you. That's all there is to it. If you have a triangle and you have a calculator, you can do trig. Well, let's just wait a sec, dude. Look at 5 and tell me what's weird. There's 2 variables, aren't there? Tangent only deals with what sides? The legs. So will tan help us with y? No. But will tan get us x? Yes. And if we have x, will x get us y? Yes. How? Please say it properly. Pythagoras. Thank you. Excellent. So since you guys are so smart, you don't even need me. You need to find x first, right? Yes. Set it up. What do I have? Do I have a theta? Do I have an O? And do I have an A? What's my theta? 30. What's my O? X. What's my A? 24. What trig am I doing? Tan what? 30 equals x over 24. Numbers on the bottom. Multiply or divide? Multiply. 24 tan 30 equals x, and x equals 13.8. Whatever. 13.8 is fine. Now stop. Everybody on their calculator should be looking at a giant number. 13.865, blah, 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 blah. Right? Right? 24 tan 30. 13.85, blah. Yes? Everybody cool? Okay, now, take that number. We know we're doing more work, don't we? So, do we know we're going to need that 13.86 again? So, should we erase it from our calculator? No. But we're going to write it just in case it gets erased accidentally. So, now we know what x is. I've got it on my calculator. Now, since I know x and we know y equals the square root of what? 24 squared plus x squared, which is 13.86 squared, right? Do I already have it on my calculator? Don't I? Yeah. So I'm going to hit x squared. There's the 13 squared. I'm going to add 24 squared. There it is. And I'm going to get an answer. What must I do with that answer? square root 768. And what's y? Y equals 27.71. That's trig. That is what back in the day, you guys are way younger than me, so it's more your grandparents. But back in the day, your grandparents would have been pulling their heads out over this. Because they didn't have calculators. They had to use paper. Yeah. And on tan, what they would do, Aiden, is they would give you, because tan can only exist between 0 and 90. They would give you a list of 90 decimal places. And you had to do math with the decimal. You'd go to the sheet, you'd say, okay, tan of 30. So you'd go to your sheet, you'd find 30. It would have a decimal place. And then you'd have to do all this math with that decimal. You couldn't go tan 30. I know, right? Okay, so now, here is your homework. No, I lie, not your homework. I'm actually going to stop for a minute because I want to show you one more thing and make sure I show you before I let you go. Turn to page 56. One sec. That font is Thunderstrike. Angles in the real world, not angels. All right. Now, guys, again, I stress, you're not stupid. Are the things we're doing right now real life?
Yes.
No, they're triangles drawn on a piece of paper, yes?
That's in real life.
Okay. So, in the real world, are all triangles flat on a piece of paper? No, because I look up and I see a triangle right up there. Yes? So obviously we need to be able to work with triangles in the real world. We're going to talk about that right now. There's two, I'm still talking. There's two kinds of angles. All right? The first kind I'm going to talk about is the angle of elevation. It has another name, the angle of inclination. Now, you guys are smart kids. Somebody direct me to elevate. Stand up, right? If I do this, my butt has elevated, hasn't it? So an angle of elevation must go in what direction? Up. Is that complicated? No. And yet every year, I don't remember which is elevation. I know, TJ. I don't understand why it's difficult. Everybody draw a happy-faced person. There I am. Now, what is something that makes me happy? A big ocean wave.
Oh, yeah.
Now, if I look at that ocean wave, my eyes make a nice straight line to it. Yes? Everyone agree? That's the horizontal. That's where I start looking from. Because when you look at something, you're making a straight line to it, yeah? All right, so that's the horizontal. Now, my brother is a bad surfer. He has wiped out, and his surfboard has gone flying into the air, and he is over here.
Is this a true story or?
Whoa! Everyone agree? My brother's behind the wave. What's the only thing I can see? Surfboard. So where do my eyes go? Up to the surfboard. Does everybody understand? Everyone understands? Where then is the angle of elevation? I started here and I looked up. Where did I create an angle? Right there. That is my theta, which is an angle of elevation. Because my eyes went from the horizontal upwards. Please highlight. Put a Mrs. Bad Crumble cloud around it. Put some stars by it. Once I look up, I create the angle of elevation. And it exists between the flat and where my eyes end up. Is everybody cool?
Yeah.
Now, you guys are smart kids. If there's a name for looking upwards, what else must have a name? Looking downwards. Now, does math make sense? Does it follow a pattern? So if the angle of elevation is looking flat and up, then what must the other angle be? Looking flat and down. So the other angle is called the angle of depression or declination. And they have the same rules. Here I am, but now I'm sad because it's the angle of depression. And I look out and I see no waves.
All you see is a nasty cloud.
I see no waves at all. So when I see no waves, what do?
You look down.
I look down at my feet because I'm sad.
Why wouldn't you look at looking?
I look down.
So I look down at my feet. Where does the angle start? Flat, where it always starts. Where did it go? Down. So here is my theta. The mistake kids make is they put it in here. That's wrong. Because it's where I start to where I end up. Looking down. So the angle of depression is from the horizontal to what direction? Downwards. Wake up, you piece. Horizontal, downwards. And then I'm going to put my Mrs. Bad crumble cloud around it, and my stars, and everything. And then over here, I'm going to write, it's the angle between, and I'm going to use the same word so it doesn't confuse you, between the flat and where my eyes end down. Does everybody understand that? So, here I am. Where's the flat? Straight in front of me. I'm looking right at the whiteboard at the back. I'm looking at 9247. Understand? That's where the angle starts. One of you has climbed up a ladder and written up on the wall, math is awesome. Thanks, Mr. Myers. Where will my eyes go? Up. Now, the first line is flat. My eyes go up. Where is the angle of elevation? Where my face is. Yes? Between the flat and the up. Now, another wise ass in here at the bottom has written, just kidding. JK. So my eyes are up and I'm smiling because I'm happy. Then somebody says, look at the floor, doofus. So I bring my eyes back down to flat. I look down. JK. Where's the angle of depression? Where my face is, but my face is no longer. What is it really?
Extra.
Because it's the angle of depression. Because you're kidding about math being great.
Math is great.
Does everybody get it? All right, now I am shutting up. Your job for the weekend is you at least do those 3. And on this page that says page 76, it looks like a lot of work, but it's only 4 questions. The answers are even on the page. If you are going to be lazy, which all of you are, really try at least at least try to do 14 and try 19. 20 is really hard. The answers are right there, yes. But that doesn't tell you how to do it. Right? Everybody good? All right. Now, what Mr. DeVries is talking about